Hello everyone, I'm Kamlakar and I'm going to post a series of videos on few programs in Python related to artificial intelligence. This will be extremely useful for those who are doing a course on artificial intelligence of TYBSc Computer Science as per syllabus of 2018-19 of University of Mumbai. If you are not, then also these videos will definitely help you to understand how to solve a problem. The syllabus of AI prescribes this book for theory and these resources for the practicals. Although it contains all the solutions, referring and understanding them may not be easy. Answers to all the searching algorithms are given in one single file, search.py, and this file contains collection of all the search functions and related classes. It is up to us to call the functions as per our requirement. In today's video, I am going to cover breadth first search algorithm on graph in Python from AI point of view. In the process, I am going to customize the program to make it simple. So let me begin. To solve BFS, the first requirement is you should have a graph. What I am going to do is to represent the entire graph using a dictionary. We will consider an undirected graph as given in the diagram. You don't need to create Romania graph, any simple graph with cities of your choice will do. Check that I have added both the links from A to B as well as from B to A for all nodes in the dictionary. This can be tedious for bigger graphs, but as I have already said, the focus is on BFS and not on the size of a graph. Let me convert this dictionary into a graph. For that, I am going to include a class called graph. The class graph contains entire graph as dictionary represented by graph underscore dict variable and its type whether it's directed or not. The init function has two parameters with default values for these variables. Mumbai graph variable declared at line 23 is used to represent the graph object. As we are passing both the arguments, default values won't be assigned. The graph class contains two functions, nodes and get. The nodes function returns the collection of nodes of graph as a list using the keys function. The get function works in two ways. If you pass only one argument representing node A, it will return the links or connections of that node as a dictionary. For example, for node Kurla, connections are Sion and Chembur. If you pass two parameters, they will represent the source and destination node and the function will return the cost as mentioned in the dictionary. You can test the output by calling the above functions. Had this been a data structure paper, perhaps I would have proceeded to BFS code. But we are doing this in AI. In AI, the approach is a bit different. Since an AI agent is supposed to solve the problems, first we need to define what is a problem. A good amount of theoretical explanation is given on this topic of the book, so please go through it to clarify the concepts. Good. Let me represent a problem by a class called problem. You will see that the class problem has two variables, one to represent the initial state and one for the goal state. Goal underscore test function checks whether a state passed as parameter is goal state or not. Path underscore cost function finds the cost by adding 1 in the existing cost represented by C to change from state 1 to state 2 using the action. Actions, result and value are like abstract functions, so I will discuss about them when I'll actually implement them. Good. Now let me add next class graph problem. This class will be a subclass of problem. To initialize graph problem in init function, I must provide initial and goal state. Check that they are initialized using init of its superclass problem. In addition, I will provide a graph. Now the three abstract functions of problem class are to be overridden. Actions function returns the available actions, means connection of nodes from a given node. For example, if node A is key and its connections are represented using dictionary, then this dictionary will be returned. Result function returns the action that generated the result. Basically, it will contain the name of the destination node. Path underscore cost function takes existing costs in the form of cost underscore so underscore far and adds the cost of path between any node A to B in it. If there is no such path, then it is considered as infinity. Infinity is a special variable to represent very large number and it is declared at the top. Below, you will also see that I have created object of graph problem and called its functions just to verify it. Great, so the code of graph problem and graph problem classes is ready. Now I'll add a class called node which will have functions to work with graph. Node class contains few instance variables and an init function to initialize them. State represents the name of node, parent represents parent node, action represents what action generated this current node from the parent node, path underscore cost represents total cost of path, depth is initialized to 0. If there is parent, its value becomes 1 plus depth of parent. RAPR function is like toString function. When you give state name of current node, it will print the information in that format. Expand function creates a list of all the connections accessible from the current node in the form of objects of class node. It uses actions function which I have already explained. To create object representation of connected nodes, child underscore node function helps. Child underscore node function creates node object using the information such as next underscore state, new underscore path. To do this, the functions like result, path underscore cost of problem class have been called, which I have already explained. In child underscore node function, action and next underscore state actually contains the same information. There are two more functions in the same class, path and solution. Path function gives how you have reached to the present node. For example, if the connections are from A to B, B to C and C to D, if you are at D, the path function on D will trace the path from D, C, B to A. Hence, I have reversed the list by returning it so that it shows from A to D. Solution function is similar to path. Path function returns the list of node objects, whereas solution function returns the state names as list. Now comes the final part, adding function for BFS. The breadth underscore first underscore search function is similar to the algorithm given in the theory. Note that it is not included in any class. First of all, import DQ from collections library. The parameter to the function is an object of problem which can make it work on different types of problems. I want to check the path between Kurla and Thane as per statement number 99. So Kurla is source and Thane is destination. After setting this up and making sure that our initial state Kurla is not the destination state, we proceed. Here, two collections have been used. Frontier, which is Q to keep collection of graph nodes, and Explode, which is a set of nodes which have already been visited. Note that it's a set because I don't want to add same visited node twice. Then, as given in theory, I extract leftmost node from Frontier, put it into Explode, generate all its children. If the child is not in Frontier or not in Explode, I check whether it is goal state or not, and if not, add it to the end of Frontier. If the goal is unreachable, then the function returns none. In undirected graph, that can happen if you specify destination node name that does not exist. At the end, I have called the function. Just check the output. From the data, you can notice that from Kurla to Thane, first you start from Kurla to Chembur with path cost of 6 and then from Chembur to Thane with path cost of 9. So total path cost will be 15. You can execute the same program for Umania map. I am sure it will work. So that's it for BFS. The link of the code is given in the description. If you have followed the program, click on the like button or give any suggestions. Do subscribe to my channel for more interesting videos. Thanks for watching.